There's a lot of junk up there. There's 30,000 pieces bigger than my fist, and we can just detect them. And then as you go to smaller and smaller pieces, stuff smaller than a millimetre can punch a hole in a spacecraft. So the vast majority of the stuff that can be damaging, we can't see it with the technology of now. Firstly, going to the movie Gravity, their concept that they're talking about there is the Kessler syndrome, where you run into a chain reaction that is rapid. And so you get one bit of space junk, hundreds, thousands, bang, 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 and that's what's happening in the movie. We're in a slow motion Kessler, not a fast one like in that, where they had hours to get out of the way and they could not get out of the way. We're in a slow motion where one bit of small space junk hits a big one, creating hundreds of pieces and we are in real danger. Let me give you the danger. Every second time the International Space Station, the Space Shuttle went into orbit, every second time they had to replace a window. Secondly, with the International Space Station, 16 times it has had to manoeuvre its multi-400-ton bulk out of the way to avoid running into something, and on 3 occasions they haven't had enough warning, and every single astronaut has had to suit up, fully up, get into an emergency escape capsule and be ready to cut and abandon ship if something hit 3 times.
Now, when you say running into something, it doesn't have to be large. This could be almost microscopic. But given the speed that it is travelling, the damage it could cause could be catastrophic.
Sure.
Yeah, the shuttle in the very early days was traveling at what you would normally imagine a spacecraft would travel at, like if you see in the movies, it's front first. So everybody wants to see in front of them as they travel forward, like in an automobile. But then they started hitting some of these space debris, and literally just a little piece of fleck of paint. The glass on the shuttle was, I don't know, it was a massive, massive thick glass, because they want to protect the crew. And this little flick of paint at that speed went all the way through, almost broke through to the very end. It would have killed the crew.
Almost.
So almost is the key. It's horseshoes, right?
Having said that,
So-
given the amount of junk that is out there at the moment, are
Yeah.
you surprised there hasn't been a major catastrophe of that sort?
There hasn't been any catastrophes with people there, and I'm a former Army guy, and we used to say artilleryman. We used to say big sky, little bullet, and that was kind of the attitude. What we're talking about here, this sort of cascading effect where a bit hits one spacecraft, it shatters because that's what we would expect it to do. That has happened a few times, but it has not had that cascading effect that some of the scientists think is going to happen yet. And I think it's just because the space industry still, if you think about it, is very early days.
So, Jason, do we simply have to wait for this debris to fall to Earth and burn up? Or is there another solution to the problem?
There are several solutions to the problem, and there are several solutions in research. And yes, and historically, you wait until a satellite burns up. And there are regulations that say, if you're at a certain altitude, you have to have a way to either enough fuel to shoot the satellite out or return to Earth. The problem is a lot of modern satellites are becoming miniaturized, and you see a lot of companies out there that are making smaller and smaller birds, and that means they have less fuel to do this. Okay, so some of the satellites, we're talking literally this big, they can fit in the palm of your hand. They're called CubeSats or microsats, and they simply don't have the fuel to what they call deorbit, which is essentially a controlled burn. So what we did was we made a electrodynamic tether. Okay, we created a system where you could stick it at the bottom of a spacecraft and unrolls an electrodynamic tether, interacts with the Earth's magnetic field. So what happens is there's a force called the Lorentz force that goes in the opposite direction. It's the force of the actual electrons, interacting with the magnetic field, and it'll pull it back down to Earth.
Wow, so you're causing, by the wire, which conducts electricity, cutting the magnetic field lines of the Earth, is creating not aerodynamic drag, but electrodynamic drag. It's actually creating drag by cutting the Earth's invisible magnetic field lines.
The good news is there is a bit of both, but yeah, the main methodology is to use the properties of electronics and the Lorentz force to add a force to drag it down.
And you're designing and building such a device?
Yeah.
So this essentially is a piece of string made out of.
It's a technology. We don't make the actual string itself, right? So we make the deployment mechanism, but the string is called Aerocon, and it's a special fiber that's got the properties of a textile. You could weave it. It looks a lot like string. It feels a lot like string. But it's as conductive as copper, which is really, really cool. It's really
It's
cool stuff.
And how long? Like 1 metre, 10 metres, 100 metres?
You get as much as you.
But what are you planning for yours to
Would
drag?
that depend on the size of the spacecraft?
Size of the spacecraft, how quickly you want to bring it down to Earth. If you're talking about these small satellites, and also depends on how high you are. So, because it's got to react with the Earth's magnetic field. So, if you're making it 150 meters, for example.
Wow.
150 meters for the tether, and you'd have to have it really thin, like a monofilament with that. Then you could get back down to Earth. If you're about 600 kilometers up there, it'll take about 2 weeks.
Wow.
Really, really quick.
That's very quick.
Yeah, by law, you have to be able to get down in 25 years.
We are suffering the tragedy of the commons. We have a common resource, which the Earth orbit in space, which generates for the Earth $1/3 of $1 trillion in income every year. By the way, the whole Earth, the whole planet, 60 trillion, $1/3 of $1 trillion. Everybody is using this resource. Nobody's taking care of it. So it's getting degraded for future generations because space travel is not going to be so easy because I'll be running into stuff. So we have to look after this common resource and tax everybody to make sure that it's clean for our children and their children.